Let's take a look at our good friend f of x equals x squared and ask the question, can we figure out the length of the arc between two given points? Now it turns out that you can using calculus, and the idea is called the arc length. What is the length of the given arc? So hopefully you've gotten the idea now that when doing calculus, you sort of want to look at really small pieces. In the case of integration with arc length, you want to actually add them up. So let's take a look at a length of arc here. Okay, so there's some length of arc. And what we're going to do is we're going to estimate it. We're going to make it larger. And how do we estimate the length of that arc? Well, we have a little right triangle. And this triangle really has two pieces. So it's measuring sort of like the change between 2 points. And we could write delta x for the change in x and delta y for the change in y, but these are using a limit. These are going to be simply dx and dy. And so what we're doing is we're summing a bunch of these, okay? And if we do a bunch of sums, what that looks like is an integral. So let's say it's the sum from a to b of what? Of all these lengths. Well, what is this? Okay, it's the square root of dx squared plus dy squared. And we're looking at this, over the entire arc. And additionally, I would like to add that, so because you're summing a bunch of these arcs, you've got to have this dx here. Okay? You can't do integration without it, because in effect, it's really two different pieces. You're looking at the individual piece right here, that's its own dx dy, but we're summing all of them over the curve across x, right? Like from a to b, or we're going from a to b dx. Now, this is not the right format for the arc length, because it's a little bit confusing, and so what you want to do is something like this. You can divide by dx, so it's 1 plus dy dx squared. And this is the formula for arc length. Arc length, in effect, in AP Calculus BC, is a formula that you want to just be able to use. Now, if we consider this particular case, okay, let's take a look at that and see what would happen. Let's say we're going here from 0 to 2. Okay, so if we're going from 0 to 2, we would go from 0 to 2, square root of 1 plus, now dy dx is 2x, and when you square that, you get 4x squared. Is that right? Yeah. And this is very common with arc length, where you end up with something that's difficult to integrate. Now, we're not going to integrate this right now. Commonly, you will see these show up as problems in which you can use a calculator. And so you want to be able to know how to use your calculator to be able to compute integrals like this. Okay? Later, we could look at some trig substitutions that will actually do this. Okay, let's just take a look at a practical example using one where you don't need a calculator. So how about this? Let's let f of x equal 2x to the 3 halves. And what we're going to do is we're going to find arc length on f between what? Between any two given points, and we'll just say we'll keep our 0 and 2. Okay, so what we need to do is set up our formula, and as the integral from 0 to 2, square root of 1 plus what? Okay, so we've got to take the derivative first. Now the derivative here is going to be 3 halves times 2, right? We're preparing to subtract 1. The 2's cancel, and so we get a 3. And then it's going to be x to the 1/2. Okay, we'll leave it like that. So that's the derivative, but you've got to square that. Okay, so we take the square of that and we get 1 plus 9x dx. Now, this is something that we can integrate. So I want to be clear. Why can we integrate this one and not this one? Just using like what I call straightforward techniques. The reason why is the chain rule, because you've got to deal with the square root. Okay, that's on the outside. But then remember, integration is an antiderivative. And so if you take the derivative, you've got to end up with what you have. And so in this particular case, if you take some root derivative, by the chain rule, you're going to have like a times x term, 8x, right? But in this case, it's not times any x, so we're okay. Okay, let me show you how to do this one without u substitution. So we know we've got this all to the 1/2. Okay, we're going to go ahead and integrate it. And when you integrate it, right, it's something to the 1/2, you add 2 halves, and so it's going to be this 1 plus 9x all to the 3 halves. So it's kind of interesting, you get back with what you had. Okay, but, okay, it's to the 3 halves, and then that would be times 2/3, right? And then just look at this part of it. So if you took the derivative, the 3 halves and 2/3 would cancel, minus 3 halves and the 1/2. But there's no 9, right? There's no times 9. If there was a times 9 here, we would be perfect. There is no times 9. We take the derivative, you would do a times 9, so you compensate for that by dividing by 9. Okay, and then we evaluate this at 2 and 0. Okay, so it's 2/27. And then I've got 1 plus, okay, well 9 times 2 is 18. I think I'm just going to write that as 19. Right, yeah, 19 to the 3 halves. And then, you know, the 2/27 you can kind of pull out of it. And then it's minus, now what we put in the 0? When you put in the 0, that goes to 0, 1 plus 0 is 1. 1 to 3 halves is just 1. Okay, and so that is the final simplified answer. Okay, so for arc length, just really think of it as a formula. What I did here with this drawing is just tried to provide a little justification for the formula. It really is using the Pythagorean theorem, but it sort of comes out in this kind of cool form. You know, no rigorous proof here. That formula works. You can just dy dx, f prime of x, same difference. And, you know, don't panic if you end up with arc length integrals that you can't integrate. You always need to know, based on the problems that you're doing, whether a calculator is permitted or not. In calculus classes, they're permitted some of the time, they're not permitted some of the time. And when you do need to know many integration techniques, like u substitution over here, to be able to do the ones that you're expected to without a calculator. And in other cases, you need to know how to do these on a calculator.